Saxon Algebra 1. Hi, Caleb. These are the questions, the problems from the homework that were challenging you. So I'm going to just tackle them in order. I'll identify each problem here. That's the lesson. That's the homework number. Let's just go through them in order and see what we can figure out. The first problem, 29.3, says use 2 unit multipliers to convert 500 feet to centimeters. So the first thing I do is write down where I'm starting and where I want to end up. Now, John tells me that I'm going to have to use 2 unit multipliers. So I'm going to draw in the boxes. This is exactly the way I want you to do it. As I draw in these boxes, I think, what am I going to put in here? I know I'm going to multiply some fractions against this original number. I'm going to put that over 1. The first thing I ask myself is, am I doing an area conversion or just length? And I can see, okay, I didn't have square feet or square centimeters, so that tells me it's not area. It's just a conversion of length, and I must need 2 stepping stones to cross the stream. So I think, okay, how do I get from feet to centimeters? They're not even in the same system, right? This is English units and this is metric. So that gives me a really good clue. I'm gonna have to go through that portal, right? It's 1 inch equals 2.54 centimeters, or 2.54 centimeters equals 1 inch. This is the only way. Well, I mean, technically there's other ways, but for us, this is the way we get from English to metric or the other way around. So I know one of them is going to have to be this. So I'm going to have to get to inches and centimeters. I want my answer in centimeters, but I'm starting in feet. So now I can see, okay, I'm going to go from feet to inches here, and then I'm going to go from inches to centimeters there, and that will get me where I need to be. So step 1 in these problems is always to plan out the journey and where we need to go in order to get to where we want to be in the end. So this I'll use in the second box, but in the first box I need to do feet to inches. So what are the 2 options I have? 1 foot is 12 inches. 12 inches is 1 foot. I know that looks like 2 very similar ways of saying the same thing, but they're fundamentally important when it comes to canceling the units. I'm starting with feet, so I want to choose the ratio or fraction that has feet in the denominator because I want them to cancel. So I copy this one into the box. This one I don't need. That doesn't fit this situation. This is the one I want because the feet now will cancel, top and bottom. That's my whole goal. So foot cancels with foot or feet, doesn't matter how you think of it. Now my number is being stated in terms of inches. That's my new starting unit. So now I need to choose one of these 2. That will take me from inches to centimeters, but I want the version that has inches on the bottom so that they will cancel. This is the one I want. Okay? It happens so many times that just the way I write them down, it just happens to work out that I end up choosing the one on the right. That's just random. As long as you write them down in either order, just pick the one that has the right unit on the bottom. So this will be 2.54 centimeters for every 1 inch. Now I'm going through the window into the metric system. The inches now cancel, top and bottom. And I'm left with 2.54 centimeters, which is, or centimeters rather, not the number, just the unit. That's what I want. So my final answer is to multiply the numbers across, and it will be 500 times 12 times 2.54 is the final answer, and that's correct. All right. So there's the conversion. You asked me a question about one more of these. It's from lesson 30, so we'll get to that one later, but I'm just going to keep the problems in order to help make it less confusing to find what you want. The second problem is also from 29. It's problem 9, and that says 2 1/4. Oh, I'm sorry, 2 1/4. 2 1/4 of what number, and I'm going to abbreviate that mainly because I don't want to write all those words out, and also because that's what I'm going to use for my variable. 2 1/4 of what number is 72? Okay, remember that we use our frickin' formula to do this, and that is F times of equals is, where F represents a fraction and of represents a total group, and is represents a special group. Once you learn how to use this formula and how to let the words guide you into the equation, these are a piece of cake. So, the fraction is usually the first thing that we see, but let's go on and do these because that helps us identify what we're missing. Remember, there are 3 different pieces of information we need, and John always gives us 2 and lets us struggle to find the third, but he mixes up which one's missing. I see right here that we have an is number. Is 72, so that's going to go right there. Of what number? That tells me that this is our mystery, and so 2 1/4 must be the fraction that will go right there. So using this as my guide and identifying these parts of the problem to correspond, I can say that 2 1/4 times the variable, which again, we use we could put an X there, and that's fine, but if we leave those letters there that stand for what number, then we tie the words in the problem to the numbers in the equation, and it's all much easier. Is 72. So that's the number that goes there. All right? That's the hard part of these problems, is learning how to match the words to the equation. Now we're ready to solve this. I see a mixed number. By now, you should know how I feel about mixed numbers. I don't like them. So I'm going to eliminate that right away. 4 times 2 is 8, plus 1 is 9. So I'm going to write this as 9/4, and I'm going to just cross that out. I'm not going to erase it. I'm not going to scribble it out and turn it black. I'm just going to put a single hash through it. Now I'm ready to eliminate this 9/4 that we're multiplying by this variable, because I want to get this by itself, right? Now, usually when we're multiplying, we divide, but I don't want to divide by 9/4. That's a mess that I don't want to deal with. So instead, I'm going to choose to multiply by the reciprocal. When we're trying to get rid of a fraction that's being multiplied, the reciprocal is a much better tool than trying to divide by the fraction. So I'm going to multiply by 4/9, and I'm going to remember to do that to both sides. I'll put that over a 1. We'll deal with that in a minute. Let's make sure this is good. This will always turn into a 1, and we see that that's true. If we multiply it, 4 times 9 equals 36. 9 times 4 equals 36. 36 over 36 is 1. Multiplying by 1 changes nothing, so we can cross all of that out. That all just disappeared on us. It turned into a 1. That's the magic of the reciprocal. Now we know that we just have the variable on this side. We can use 2 letters as a single variable. That used to blow my mind when I was starting out, and I thought, what? 1 letter, not 2. We can use 2. It's just helping us remember what it means. Now we just have to simplify over here. I look to cancel before I multiply. 9 goes into 72 8 times. And once we turn both denominators to a 1, we know we can't cancel anymore, because in order to cancel, we have to have a top number and a bottom number that we can divide. And as long as these are 1s, that means we're done. So it's just 8 times 4, so what number equals 32? So that means That means that 32 is the number. When you multiply it by 2 1/4, you get 72. All right? I don't want to tell you a story about that. That's the right answer. Next page. Except my paper doesn't want to let go of each other. Okay, next one. 2915. This is a fraction equation. Ready? 1/4 x plus 1/2 equals 7/8. All right? Just writing that out is really helpful to me because I noticed some things. The first thing I notice is that there's a lot of fractions in here. And you know, I'm not afraid of fractions, and sometimes they're cool, but generally speaking, if I can get rid of fractions, I'm gonna get rid of those denominators as fast as I can. They just confuse things. And whenever possible, I wanna get rid of them. So I have two strategies for getting rid of them. One works if it's an equation, and one works if it's not an equation, which is what we call an expression. Remember, I can tell if it's an equation because it has an equal sign in it. This one has an equal sign, so that tells me I can blow up my denominators and get rid of them all together. The way that I'm going to do that is to multiply all terms by the least common multiple of these denominators, all right? I'm gonna show you what that means, but those are the words that tell us what to do. 4, 2, and 8. Well, I can see that 4 and 2 can fit into 8, so if my least common multiple is 8, it's gonna take care of all of these guys will be able to find themselves in there. So I'm gonna multiply this term by 8. The plus sign tells us that this is a second term. And then I'll multiply this one by 8. So I kind of write that up at the top so I can see it, and I can also cancel it. 8 and 4 cancel. I'm going to get 2 here, 1 down here so I can ignore it. And then what I'm going to do in my next step is I'm going to multiply the 1 by the 2. Same thing here. 8 and 2 cancel. I'm going to get 4, and I'll multiply that by the 1. And this turns to a 1. So obviously I don't need a denominator anymore. These two cancel all together, and we don't have anything left to multiply by the 7. So now I can rewrite this. 2x plus 4 equals 7. Wow. Once we do that, this whole thing turns into a very simple equation, doesn't it? We're trying to isolate our x. Oh, this is the 3 friends thing, right? And so first we send home this one. And we get 2x equals 3. These are the best friends, right? This is that third wheel friend. And then we divide both sides by 2. And we get x equals 3/2. And that's the right answer. Yay. It's really important, Eli, that you follow the steps just the way I'm showing you. The reason that I do that is because the steps can help you remember the work. All right? It's very hard in algebra to remember how to start a problem and exactly what the steps are. If you follow my process, it will help you understand and remember how to do the problem. I do not think that I have all the answers and will never learn anything new, but I've been teaching this very book for 20 years. That's a long time. And I've done it year after year after year. So I've taught this book 20 times. What that means is I've thought about the easiest way to do this and the best way to teach it an awful lot. And so I'm asking you to trust me that I'm not wasting your time with all of this. This is really the best way to do it. And if you will copy these steps and format your problem just like I do, it's going to make your job of learning easier. All right, next problem. I also don't believe in wasting a lot of time on writing if you don't need it. I only write down what I need to write down. So I'm not going to waste your time or your ink or your wrist strength on a bunch of nonsense. Okay, 21. Simplify by adding like terms. I'm going to write it down exactly like it is in the book, and then we'll talk about it from there. Okay, the trick of these problems when we're adding like terms is that the letters and the exponents on the letters must match. In order for them to be like terms, in order for us to be able to combine them by adding or subtracting, as the case may be, we have to make sure the letters and exponents on the letters match exactly. Which is why I don't like to write the problem down like this, is because John has jumbled up the order of these letters and it makes it way harder to compare. So what I like to do is, as I'm copying the problem out of the book, I fix each term so these are in alphabetical order. So that's what I'm going to do now. But if I were a student doing the homework, I wouldn't even write this. I would just work from this in the book and say, okay, the first one, let's see, P, then X, and X has a squared, and then Y. That's alphabetical. -7. Okay, this one's, whoops, this one's right to begin with, so that's good. And then this one is out of order too. P, X squared, Y. I'm looking to make sure that these match even though they're not in the same order. And then this one's easy, okay? Now, when I look really carefully, I see, okay, these letters and the exponents on them, they're all exactly the same. What that means is I can combine them, and the way that I do that is to ignore the letters now and focus on the numbers and the signs, and to combine those. 4 minus 7, that much is -3. -3 plus 3, okay, it comes to 0. P x squared y minus 4, right? All of that adds to 0. And if we have 0 of those, then we can just write the answer as -4. So that's why all the letters and exponents go away, is because once we determine that they match and we add the numeric coefficients, it comes to 0. And 0 multiplied by all of that disappears, and we're left with just that much. That was extremely satisfying to make all that go away. That was 21. We have one more from this lesson, 23. Expand by using the distributive property. Okay, I'll copy it. All right, so distributive property. As soon as I hear those words, I automatically think of this, right? We want to take this outside term and multiply it by the first part of the binomial, and then put this sign in between, and then multiply the second part. Whoops, this is in the wrong place. This should be there. Okay, so now I look at these, and I see this -2, and I think, oh, that scares me a little bit. Do I need to flip that to take care of the trapeze? And then I think, no, don't do that yet, because when we multiply this by this, I see I've got more x's. So something's gonna happen there, and I'm not gonna worry about it until I do the multiplying. I do see this down here though, y to the 0. I remember that any variable to the 0 power or number equals 1. And 1 we can ignore because 1 times anything doesn't change it. So here's what we can do. As soon as we see that 0 exponent, we can just cross that variable off. We don't have to deal with that at all. So that's nice. And then the other thing I want to remind us is that when we're multiplying together 2 matching bases that have exponents on them, we can simplify that by adding the exponents. That's called the product rule for exponents. It's super important, it's super useful. We're going to talk about it a trillion times over. So I'm just reminding myself of that. When I go to simplify these, if the bases match, I'll be able to add the exponents. So let's start. We're going to multiply this whole clump times this whole clump, and we'll go one letter at a time. So I've got x, and I'm just going to write this out, minus 2 plus 2, right? Because I add the exponents. And then our y, remember, it's if there isn't an exponent on it, we can add one. 1 plus 1 gives us 2. So when I multiply that term against that term, this is the product that results. Now I'm going to take that plus sign and put it back in. And now I'm going to multiply this term, which is really just that big, right? Because that y to the 0 we can ignore. These. Now this one's got a number, so I'm going to deal with that first. We always handle numbers first. There's nothing in front of this one, so I can just put the 2 down. I'm multiplying an invisible 1, if you want to think of it like that. 1 times 2 is 2. X, we have our minus 2, and then we add 3. We're using the product rule. And then we only have the 1y, so I'm just going to write it like that. I'm not even going to bother putting the 1 there because we don't have to add it to anything because that went away. All right, now I'm ready to simplify. Minus 2 plus 2 equals 0. So this ends up being x to the 0 power. It turns into a 1, and it goes away. So I can draw a line through all of that. This becomes y squared. And then over here, the 2 is fine. Now I can combine this. What's minus 2 plus 3? That's just, it equals 1, right? So I can just write x. I don't have to put the 1 on it. And then the y. So there's my final answer. All right. Beautiful. So there were lots of little twists and turns in that problem that made it interesting, and I can see why you could get confused on that. All right, that's the end of the problems. There were 5 of them from lesson 29 that you asked about. There are those. And then you were also curious about lesson 30, problem 3. And that is another unit multiplier. So we're beginning and ending with unit multipliers. Use 2 unit multipliers to convert 10,000 feet to centimeters. Okay, John tells us that we're going to need 2 unit multipliers. So I'm going to draw in the boxes with the multiplication dots in between. And as I do it, I'm thinking, okay, what kind of a problem is this? I know I need 2 because John told me. I'm going to put that over a 1 because it makes everything look more balanced. Is this an area problem and we're doing it twice because we have to convert each dimension? Or is this a stepping stones across the river type problem where we have to use more than 1 stone? Well, there aren't square units here, so that tells me right away this isn't an area problem, and I'm not going to use the same unit twice. This is a stepping stone style because we're not dealing with squared units. So I think, okay, feet to centimeters. Well, now I think this is English units, this is metric, so I have to go through the portal again. This is just like the first one, where I know I'm going to have to go 1 inch equals 2.54 centimeters, and 2.54 centimeters equals 1 inch. I know I'm going to have to use this. That's the portal that we use when we want to go from English to metric or metric to English. That's the only way we do it. So I know I need to get to inches, but I'm in feet. So that tells me, okay, this one's going to be feet to inches, and this one's going to be inches to centimeters. This work We're gonna soon simplify our work, and we don't have to show all this other stuff, but we're always gonna show what we're trying to accomplish in each multiplier box. All right, so this is really important that you write this down. And until you get really strong at these problems, I always want you to write down your choices. These are our choices for the second box, but what about the first box? Feet to inches. Oh, I know the relationship between that. 1 foot is 12 inches, and 12 inches is 1 foot. And yes, that does mean two different things because it's important we choose the right one for our problem. We've got a starting unit of feet, so we want to choose the ratio or fraction that has feet on the bottom so that we can cancel appropriately. That is this one. So I'm going to write it in here, 12 inches to 1 foot. Now I check to make sure that cancels the way I want it to. Yes, one top, one on the bottom. Now my starting unit is inches. All right, that sets me up for the next box, doesn't it? Now I want to choose the version of this that has inches on the bottom. And that's this one. It's so funny how they always end up on the right. I don't plan it that way. 2.54, I'm just copying it in. 2.54 centimeters for every 1 inch. I'm paying attention just to the units to make sure that I can cancel them. Now my answer's in centimeters, and that's exactly what I want. Yay. So when I cancel my units through and I end up with the unit, the answer that John wants, I know that I've got all the multipliers I need and everything set up. John isn't always going to be so nice as to tell us how many boxes, how many multipliers we need. Soon we're going to be on our own to figure that out. So it's important that we learn that the way we know we're done is when we get to the proper unit. Now all I have to do is collect up numbers. I notice right away the denominators are 1 all the way across, so I can ignore them. They're fine. And my answer is going to be 10,000 times 12 times 2.54 centimeters. And that's the right answer. Stick with this, Eli. We really want to get this presentation clear in your head. Like I said before, it's 100% fine that you work with your dad, but he may have different ways of doing these problems, and I want you to teach him this way because this is what you're going to want to do, because we're going to be building on these and we're going to be making it harder and harder and harder. So you want to understand this process of handling these, all right? When I first started teaching this, I thought, oh no, I've got a better way. I'm not gonna do it John's way. And after a couple years of doing the higher level classes, I realized, no, this is what I need to be teaching everybody. So I learned my lesson the hard way, and I don't want you to have to do that. This is the presentation we want, okay? And if your dad has any questions about that, send him to me. But you teach him the way to do it so that he is on the same page with us, all right? Okay, those are the 6 questions that you asked me about. Eli, I can do this for you any time that you're stuck on some questions. So feel free, like I said, just text me and say, hey, I need some help with, and then tell me the lesson number and the problem number. And I will sit down and sometimes I'll just write it out if there aren't a lot. I'll just write it out and send you a picture. But other times, like this time, it's just as easy for me to do a video so I can actually explain why I'm doing what I'm doing. Let me know, message me back right now and tell me either that helped or no, I'm still confused and I need something else. I look forward to hearing from you. Thank you, bye.